Welcome to ECE 320 Digital Electronics for Spring 2022. Now, electronics is, in my opinion, one of the hardest courses in the ECE program. The reason being is we're dealing with nonlinear devices. Now, the prereq for electronics is Circuits 1. Back when you took Circuits 1, you looked at solving circuits like this. Given a resistor circuit, I can solve by setting up n equations and n unknowns. This is a linear circuit, so what I can do is write my equations using voltage nodes, current loops, put it in matrix form, and then solve using MATLAB. That works for linear systems at DC. If I have AC components, here we are, I can use the phasor representation. The capacitor becomes a complex number, 1 over j omega c. The voltage source becomes a complex number. The real part's cosine, minus j is sine. Set up n equations, n unknowns, and solve. Only now I'm using complex numbers. So again, that's something that you're familiar with for linear circuits. What we're dealing with are nonlinear elements. You've got silicon. Silicon is a semiconductor, and what that can do is its resistance changes with temperature. With silicon, I can do things like build a thermistor. A thermistor is just a piece of silicon. As the temperature goes up, I get more and more thermal electrons and resistance drops. Likewise, by measuring resistance, I can tell you temperature. That's just a piece of silicon. If I take two pieces of silicon, put them side by side, and dope them, do a thing called doping, when I can get N-type or P-type, that's what's unique about silicon. I can get two different types of material. I can get a diode. Diodes look like this, or in Circuit Lab, diode would be this puppy. Diodes are nonlinear elements. They allow current flow one way, but not the other. Very different than a resistor. When you have a diode in a circuit, kind of like this guy, I now have the same problem I had back in Circuits 1. I can set up n equations, n unknowns to solve. However, these equations are nonlinear. Solving nonlinear equations is a lot harder. So a diode is two types of silicon put together, P and N. A transistor. Going down here. A transistor is three types of silicon, NPN or PNP. When you do that, I get another nonlinear element. This has a diode in it. That little arrow means diode, but this is a current-controlled current source. Back in Circuits 1, if you ever had a current-controlled current source, let's see, something looking like this. Here we are. That's a current-controlled current source. That's a transistor. It's nonlinear because I have a diode in it. It allows current to flow one way but not the other. And the current then gets amplified up to a limit. If my power supply can only output 100 milliamps, this can't amplify the current more than 100 milliamps. That gives you another nonlinear element. So electronics is all about analyzing circuits with nonlinear elements, and that's what makes it hard. I'm now dealing with solving nonlinear equations. Where we're going to be getting to in electronics is we're going to start out with a review of Circuits 1. Then we're going to talk about semiconductors and silicon. What you can do with a single piece of silicon, which actually isn't a whole lot. You can build a temperature sensor. That's about it. But that's the foundation for other types of semiconductors. If I take silicon and dope it, I get a thing called P-type silicon and N-type silicon. Two very different materials. P-type silicon, all the charge carriers are positive. N-type silicon, all the charge carriers are negative. Put the two together, I get a p-n junction or diode. Stuff you can do with a diode is I can build an LED. I can build AC to DC converters, max bin circuits, clipper circuits, things you can do with a diode. If I take three types of silicon, put them together, I get a transistor. With a transistor, I can build a switch, have something wimpy like a 555 timer turn on and off a speaker, turn on and off a motor. I can use an op amp and have the motor or a fan being turned on and off with temperature. I can build an H-bridge, have the motor go forward or backwards. I can convert one DC voltage to another, and I can convert DC to AC. If I take four types of silicon, put them together, I get a semiconductor relay. This is like a diode that I can turn on and off. And I can also do things like build AND gates and OR gates from transistors. We'll be looking at different types of logic called DTL logic, as well as what's actually used in computers now, CMOS logic based upon MOSFETs. So that's where the course is heading. Again, one of the harder courses in the curriculum, mainly because we're dealing with nonlinear devices. So that's where we're heading in electronics. A little bit of background on the course information. The instructor for this course is Devices Day for the in-person section, and myself, Jake Lauer, for the online and live streaming section. Class time is at 11 a.m. and Ag Hill 234 if you show up in person. It'll also be live streamed at 11 a.m. All the lectures are also recorded and posted on Bulletin Academy, so if you miss a lecture or it's a really cold day like today and you don't really want to walk across campus, you're welcome to watch the lecture online. Labs are part of the homework sets. There's no separate lab write-up. Typically what the homework will do is you'll have design on paper, simulate in circuit lab, then build it. To build it, you're going to need a lab kit. The lab kits come from Amazon. We'll talk about that in just a sec. And there's a couple extra parts that you need. Just pick those up from me in ECE 201. The extra parts are free. And my office hours are Monday, Wednesday, Friday, 8 a.m. on Zoom. Pretty much whenever I'm around, I'm fair game. The bulletin description. Let's see. ECE 320 is digital electronics. It's the characterization, modeling, and analysis of digital circuits using diodes, BJTs, FETs, op-amps. It's required for all electrical and computer engineers, so everybody should be signed up for 320. 321 is analog electronics. It's the follow-on to digital electronics. Digital electronics 320 runs the first 10 weeks of the semester. The last 6 weeks is analog electronics, so it should fit your schedule if you want to take it. All electrical engineers should take 321, analog electronics. It's optional for computer engineers. If you're a computer engineer and you take it, it counts as a 2-hour technical elective. 321 is the characterization, modeling, and analysis of analog circuits, including diodes, BJTs, FETs. It does things like look at building amplifiers so that you get a sine wave out rather than a square wave out. High power amplifiers, so you can drive a speaker motor with an analog signal rather than the digital. Filtering, sensors, and building amplifiers at the transistor level. So we're going to talk about 320 digital electronics in this presentation. The objectives of 320 are by the end of the semester, you should be able to explain how current flows in a semiconductor via holes and electrons, be able to explain how diodes and transistors operate, be able to design and analyze diode circuits using nonlinear and ideal diode models, design and analyze transistor circuits with binary outputs, and analyze and design op-amp circuits with binary outputs. Again, the binary is 320 digital electronics. Analog outputs, when you get a sine wave, will be 321 analog electronics. The resources that you need in this class: you're going to need a calculator that's capable of doing complex numbers. Again, you probably saw that at the end of 206. Once you start dealing with AC signals, you need complex numbers. Real numbers work well for DC. I just have a number. For AC, I have a sine and a cosine term, or in polar form, amplitude and angle. I need two numbers to represent an AC signal. That's a complex number. So anytime you're dealing with AC, you need to use complex numbers, which is pretty much from this point onward in electrical computer engineering. I strongly recommend the HP35S. Most people use TI-84 Plus. Your pick. Just make sure you can do complex numbers because you're going to need it when you get to the tests and quizzes. You need the ability to make videos and preferably post them on YouTube. Again, typically on the homework, it's design on paper, simulate in circuit lab, then build it and demonstrate it. A good way to demonstrate your homework is make a YouTube video. You need a multimeter that can read 1 volt AC. If you're doing the labs in person, those are in room 211, I think, and 237. If you want to do the labs at home or in your dorm room, you need a multimeter that can read AC voltages. That's about $29 from Amazon. If you're doing the labs from home or in the dorm, you need a lab kit, so you can actually do the labs. Those are $18 from Amazon. That's the great thing about electrical engineering. Our parts are fairly cheap. It's a little expensive, but then we don't have a textbook in this class, so you save your money there. You're going to need to pick up a few extra parts that aren't in the lab kits. Those are free. Just pick them up in ECE 201 anytime you want. And you need a Circuit Lab account. Again, Circuit Lab is free. It's a really, really nice circuit simulator. I really like it. It's a drag and drop program like this to build a circuit. And we're going to talk about this in a later lecture. It's just drag and drop. So I can say here is a voltage source, here's a capacitor, I have a resistor, I'll hit R to rotate it, drag and drop to connect, double click to change the values, and so on. So Circuit Lab is really slick piece of software. And it's free. I like free. Evaluation procedures. For the online section, we're going to have quizzes, homework, and final exam. Each has equal weighting. All the weekly quizzes averaged together will be 1/30 your grade. All the homework averaged together is a 30-year grade. And the final exam is a 30-year grade. The grading will be fixed scale, curve down but not curve up, meaning if you have a 90%, guaranteed you have an A. Doesn't matter what the class average is. You got a 90, you got an A. If you have an 89, it may or may not be an A, depends upon the curve. Last semester, 89 was an A. It depends upon the curve. Sometimes my quizzes are a little bit more aggressive than I thought, so I might curve down. But if you work together, you study, well, when I say work together, not on the quizzes, on the homework, if you work together, you study together, you learn the material, so that when you work alone on the quizzes, and you can demonstrate the material. If you get a 90, I'm happy to give out A's. The textbook for this course. The textbook most people use is on Bulletin Academy. It's free. There's also Electronics Tutorials, which is a very good website, has lots of information about all sorts of courses. That's another good resource. If you would like to have a hard copy of a textbook, I recommend Microelectronic Circuits by Jaeger. The edition doesn't matter. Go to Amazon, wherever your favorite book source is, find an older edition that's used. This one is $9. It's a pretty good textbook for $9. The new ones are like $200, $300. Don't buy a new one. The new ones have the homework problems, the current homework problems in the textbook. I don't use the textbook's homework problems because I like posting the solutions, and it violates copyright if I do that. So I make up my own homework problems, meaning it doesn't matter which edition of the textbook you use. Diodes worked just the same back in 1980 as they work today, so again, the edition doesn't matter. The lab kits that you're going to need. As I mentioned before, each lab or each homework set typically has 3 parts. The first part you design on paper. The second part you simulate in Circuit Lab. The third part is to build it in hardware. To build it in hardware, you need hardware, of course. That's what these lab kits are. This is from Amazon. It's 18 bucks. Has breadboards, resistors, wires, all sorts of useful stuff. The resistors I don't like. They're almost impossible to read. So typically what I'll do is I'll go to places like Jamco and get a bunch of resistors that I can read, the little brown ones. These are the blue resistors, and as far as I can tell, all the lines are black, 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 so I can't read the colors. You also need a power supply. The power supply is anything between 6 volts and 16 volts. If you dig through the junk drawer in your house, almost every house has a junk drawer full of old power supplies. Find one that's between 6 volts and 16 volts, and that'll power your breadboard. If you can't find one, a 9-volt battery also works. You're also going to need a multimeter that can read down to like 1 volt AC. That's really more for analog electronics, a little bit on digital electronics. But for example, this guy right here, the Lova multimeter, is fairly cheap. It'll read frequency, it'll read AC voltage, DC voltage, resistance. You're going to need like this. First, every self-respecting electrical engineer should have their own multimeter. In terms of the syllabus, I talked a little bit about that. On Bulletin Academy, Let's go back one. If you go to Bulletin Academy, this is what it looks like. This has quite a few courses in the ECE program. If you click on 320, that has digital electronics. Bulletin Academy has a couple different sections. You've got the syllabus, homework and solutions, best of 320, resources and comments. Syllabus is this page. The syllabus has each day what we're going to be talking about. If you click on the links, here's the lecture version of it. Again, later on, we'll have the Circuits 1 review. That's in a portrait format. In landscape format, when I go through the slides, this is what I used. The landscape format just presents better. Same content. You've got a YouTube recording of that lecture. So if you missed the lecture or you really like it, you can rewatch the lecture over and over again, invite your friends over. If you're into binge watching, this is a YouTube playlist that has all the lectures for the course. So if it's a slow Saturday night and you want to binge watch all the lectures for electronics, you can do that eventually. There we go. So there's all the lectures for ECE 320 electronics on a playlist. Typically in class, we'll have a handout. So this will have the handouts that we're covering in class in case you're at home live streaming and you want to play along. There's also the solutions on the back. And typically there's a homework set. Each week there's a homework set. So this is the homework for week number 1. If you miss it, here it is. Once the homework is turned in, I'll post the solutions to the homework. And then once you take the quiz, I'll post the quiz and the quiz solutions too. Useful for studying for the final. That's this page right here, the syllabus. Under homework sets and solutions. These are the homeworks and solutions for the past 5 semesters. So if you want extra problems to work on, to study on, these have all sorts of problems you can work on, along with the solution if you want to check your answer. If you get stuck on a homework problem and you want to get some help, this is a good way to go, good place to go to see how do you solve similar problems. Again, each semester I change the problems around a little bit, so it won't be exactly the same, hopefully. But you'll kind of get the idea of how to solve similar problems. I've got the quizzes. Again, each week there's typically a quiz. Here's the quizzes and the solution to that quiz. Occasionally there will also be YouTube videos, especially for like fall 2021. At fall 21, there were students taking the class in person as well as online. For the online students, I recorded the solutions in a YouTube video so they could see me going over the solutions as well. And they're still up on YouTube, so if you want to sit there and kind of watch as I go through the homeworks or the quizzes, they're available. That's under homework sets and solutions. Best of 320 is kind of fun. Typically in the homework, there is a written portion, circuit lab simulation, build it and demonstrate it. One way to demonstrate it is make a YouTube video. Some of the better YouTube videos I posted up here on Bulletin Academy, with students' permission, of course. So these are kind of fun to watch, see what other students have done. It's also nice to put on your resume. Employers have often mentioned that if you would put links to your better class projects and term projects on your resume, they'll click on them. It's a lot more fun for the recruiters to watch a video, and it kind of helps differentiate you from all the other students in the world. Under resources, here's the textbooks you have, and a YouTube link or Amazon link. Oops, that's a different one. So if you want to have this textbook, here's a place to get it from Amazon. Again, get the cheapest version. Various circuit simulators. We're using Circuit Lab. Really, really nice version. I'd use that. MATLAB is actually very useful too. If you want to get MATLAB on your own computer, here's a link to get MATLAB. Help on HP35S calculators and various fun sites. And comments from the class. So that's kind of walking through Bulletin Academy. The weekly quizzes. Typically the way the course runs is We'll have a lecture on various topics. Like the first week, we'll talk about Circuits 1 review, complex numbers, MATLAB and Circuit Lab. We'll have a homework set. You turn in the homework on Wednesday next week, since Monday's a holiday. We'll go over the homework the following day. Then the following day, there'll be a quiz on the homework. Homeworks you can work together. The quiz is to make sure that you understood the homework. You weren't just giving moral support. Again, homework you can work together. Quizzes are individual effort, so please do not work together on the quizzes. What I do on the quizzes is I make each quiz different. Like one resistor will be a function of your birthday. If you're born on January 1st, it's 101 ohm. Also, I check Chegg on the quizzes, so please do not post them on Chegg. The quizzes are on Blackboard. You've got a 2-hour time limit. Again, trying to keep them off of Chegg. Usually Chegg can't get the solutions within 2 hours, and you're supposed to be using Chegg anyway. You can start the quiz anytime between 6 a.m. and noon on quiz day. And on quizzes, again, do not work together. Do not use Chegg. I get kind of upset when I find the quizzes posted on Chegg. And I do check that. But here's the dates for the quizzes if you want to plan your schedules. In terms of HighFlex, for Sp22, you can take the class any way you want. There's a section. Section 1 is offered in person. There's also online and live streaming. That's Section 2. You're welcome to take the class either way. However, the grading is different. Dr. Day grades his class a little bit different than the way I grade my classes. So whichever one you take, turn in the homework to whoever you're signed up for, and take the corresponding quizzes and tests from whoever you're signed up for. The online section has quizzes on Blackboard. Dr. Day's section, I believe, are in person. And of course, legal stuff. So if you have special needs, let us know. Academic Honestly, when you graduate, you're going to be building flight controllers, defibrillators, pacemakers. This is stuff you're going to need to use to do your job, and people's lives kind of depend on it. So if you're able to get through the class without learning anything, that's not the point. The point is, here's material you're going to need when you graduate. Do your own work, learn the material, because you're going to need it when you graduate. Academic Honestly, do your own work. Veterans and soldiers, again, if you have a problem, you can't be around, let me know, we'll work something out. And attendance is expected. Your choice, in person, live stream, watch the YouTube videos, but again, attend one way or the other. So that's kind of an overview of ECE 320. It's, in my mind, a pretty fun course. It's where you start dealing with nonlinear devices. It's also a hard course. One of the things I'm accused of is being tricky. What I think about the junior year is that this is probably the hardest year in the curriculum. The reason being is we're changing the rules on you. You can kind of get through the first 2 years of NDSU by memorizing. Once you get into electrical engineering, you can't memorize every circuit. Instead, it's concepts. Like in Circuits 1, you learn current loops, voltage nodes, Thevenin. Those concepts always apply. If you try memorizing circuits and I give you a different circuit, like if you memorized how to do this circuit and suddenly I add a resistor, say here to here, if you memorize the circuit, you're stuck. I don't know what to do. If you're doing voltage nodes or current loops, it's not a problem. And that's kind of what we're doing. My job is to see that if you're trying to memorize your way through, you're not going to get through. If you're learning the techniques and concepts, then you do get through. So the junior year is suddenly where we change the rules. You're not learning, or you can't get by with memorization anymore. You've got to learn the concepts, techniques, and tools. That's my opinion why this is the hardest year. You got to change your learning style once you get into electrical engineering. But it is a fun course. You start learning things like how to actually build stuff with diodes, transistors, and semiconductors. I can start building AC to DC converters, clipper circuits, build sirens that come on when the temperature drops below 0 degrees. I can start building motor controllers. And that's why you went into engineering. You want to build stuff. This is the course when you look at how to actually start building stuff. And a good way to think about electronics, this is the interface between a microprocessor and the real world. Microprocessors typically have binary inputs and binary outputs. This is how to convert something to 0 to 5 volts to drive the processor, how to convert something that's low power, binary, to something high power, so you can drive an LED, motor, all using electronics. So that's the introduction to ECE 320, and I hope you enjoy this semester. The first lecture is a Circuits 1 review.